Now, the unit circle. We're going to be chopping a lot out of this section because usually what we'd go through is we'd go through a lot of how to derive the unit circle, how to memorize the unit circle, what creates the unit circle. But since we're kind of in this situation, we're just going to go with the assumption that you guys have the unit circle available to you and that you're just going to be reading off it. And as such, what that means is I'm sort of going to go through a brief little talk about what the unit circle is, and then I'm going to show you how to use the unit circle. So as I go through, you'll see me putting an X through a lot of the notes. You guys will not be responsible for any of the notes that I put the X through. So please, 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 please keep that in mind. Now, a unit circle is a circle centered at the origin of a coordinate plane and the radius is 1 unit. The equation of a circle centered at the origin with radius r units is x squared plus y squared equals r squared. Since we said that the radius of the unit circle is going to be 1 unit, we get x squared plus y squared equals 1. So, for example, if we had a circle centered at the origin with radius 3, it would be x squared plus y squared equals 9. If it had radius 10, x squared plus y squared equals 10 squared. But the big one that we're going to be focusing on is this bad boy right here, where the unit circle is x squared plus y squared equals 1. We can use this to determine whether a point is on the unit circle to determine the value of one coordinate given the other. So a point lies on what we call a unit circle if it fulfills x squared plus y squared equals 1. Determine if 1 over 2 comma negative 3 over 2 fulfills this. Well, that would give me 1 over 2 squared plus negative root 3 over 2 squared. And we'd have to check to see if this equals 1. 1 over 2 squared is 1 over 4. And then that would be plus 3 over 4. Does that equal 1? And we see that it does equal 1. So that checks out. Now, why is the unit circle important? I'm actually going to do a brief little lesson on that before the next chapter because I feel it goes a bit better with sinusoidals than it goes with what we're looking at right now. If the x-coordinate of a point on the unit circle is 3 over 4, locate and find what the y-coordinates of that point would be. Well, we go 3 over 4 squared, and then plus y squared equals 1. 3 over 4 squared gives me 9 over 16, plus y squared equals 1. I move the 9 over 16 to the other side. Y squared equals 1 minus 9 over 16. Or that would give me y squared equals 16 over 16 minus 9 over 16. Y squared equals 7 over 16. And I take the square root. So I get y equals plus or minus root 7 all over 4. And you notice that we'd have 2 points right there because I'd have the positive and I'd have the negative. The y-coordinate of a point on the unit circle is negative 1 over 2. Locate the point and find the x-coordinates of a point. So I go x squared plus, and the y point is negative 1 over 2 squared equals 1. X squared plus 1 over 4 equals 1. X squared equals, and I'm just rushing ahead a bit here, 3 over 4. Or x would equal plus or minus root 3 all over 2. Now, the unit circle is useful in comparing angles in degrees and radians and finding the exact values of the trigonometric ratios. This is the really, really important one. We use it to find exact values of trig. Some points on the unit circle correspond to the exact values of the special angles learned previously. If you guys recall this was for Math 20. Our special angles are 0, 30, 45, 60, and 90, or in radians, 0, pi by 6, pi by 4, pi by 3, and pi by 2.